Hi everyone, it's Miss Green and Lumi. How's everyone doing? It's good to see all of you. Lumi is so gluttonous. He just wants to eat his snack. Lumi, say hello to friends. Say hi everyone. So nice to see you all. Say hello. All right, I'm just going to give him the rest of his chicken treats. And that's all he cares about. There, say goodbye. Goodbye, everyone. So nice to see you all again. Okay. He is gone because all Lumi is interested in is his snacks. Well, I'm so excited to read you another read aloud. This one is called Things That Float and Things That Don't. It's written by David Adler and illustrated by Anna Raff. What do you notice on the cover? Yeah, you're right. There is sort of like a little swimming pool in a big tub. And there's a family and a pet. And there are things in the water. What do you notice about the things in the water? The little car and the ball. Are they sinking? Are they going down? Or are they staying on the top and floating? Let's open up and see what else this book is going to tell us about. Our world is covered with rivers, lakes, seas, and oceans. More than 2/3 of the surface of the earth is covered with water. Before there was planes, people traveled across oceans. How do you think they got there before there were planes? If you said boats, you're right. And they traveled from one continent to the next. They traveled and moved things over rivers and across lakes, of course. Before they could travel or move things by water, they had to know what things float and what things don't. A large boat that might weigh thousands of pounds will float. Interesting. Look at the boat. And it's floating. That means it's staying above the water or right on the water's surface. A whole crowd of people could be on the boat and it would still float. How come? But if one of those people dropped a small pebble, a little tiny rock, into the water, the pebble would sink quickly. Pebbles don't float, little tiny pebbles. Why is that? What do you think? Tell us what you think. You could have fun guessing which things float and which things don't. So what do we have here? We have a ball. We have a little boat, a little sailboat. Can you guess which things float and which things sink down to the bottom? Fill your sink about halfway with water. Now you need to do this with your grown-ups. Get a little tiny penny. A penny doesn't weigh that much. It's pretty light. But if you put it on the surface of the water, it falls right to the bottom. Plunk! It does not float. Get an empty plastic water bottle. Fill it about halfway with water. It's much heavier than a penny. But see what happens when you put it in the sink. Guess what? It floats. So the penny sinks, but the water in the bottle doesn't. I wonder why. Many things move around the house. Things that won't be damaged by water, make a list of what you found. Next to each item on the list, write whether you think it will float. One by one, put each items in the sink. So here's a little list. It says, does it float? And there are 3 columns. The first column would be the things that you collected. The next column would be my guess. What do you think? Do you think these things float or do you think they sink? And the last column would be the answer. This means you're actually going to try it out. And then you're going to fill in the answer. So we have a little toy car, little ball, and an apple. How often did you predict correctly which things float and which things don't? It's not just weight that determines whether something floats. It's also the object's size and shape. So, make your list and guess, and then test your theories out. Get a piece of aluminum foil, form it, squish it up into a ball, into a very loose ball, so it's not very compact and tight. Place it on the surface of the water. What happens? Does it sink or float? I still see it on the top. It floats. Now crush the loose ball into a very tight ball. Take that same piece of foil and crush it into a very tight ball. Place it on the surface of the water. What happens? It sinks. The aluminum foil weighs the same whether it's loose or tight. But the second ball takes up a lot less space. That's something that you're going to learn later on called density when you get to a higher grade. Its weight relative to size is much greater than the first ball. The density of the second ball is greater than the density of the water. That's why it's sunk. There you see, one loose and one really tight ball. What's density of water? Have you ever filled a bucket with water and tried to lift it? Water is really heavy. A cubic foot of water, enough water to fill a box 1 foot high, 1 foot wide, and 1 foot deep, weighs a bit more than 62 pounds. Well, that's a lot. That really is. There we go. There's the bucket filled with water. Something has a lower density than water if it weighs less than 62 pounds per cubic foot. Well, there it is, right here. You're going to learn more about that later in higher grades. Something with a low density than water will float. Like, what do you see here? You're right, a feather or a leaf. Do apples float? What do you think? 1 cubic foot of apples weighs about 40 pounds. Look at all these apples here. It weighs a lot. That's less than the density of the water apples float. Does a bar of soap float? Did you test that one out? Does a bar of soap stay up, float, or does it sink? 1 cubic foot of soap weighs about 50 pounds. That's less than the density of water. Soap floats. There's the apple. What is it doing? Is it floating or is it sinking? Is it going down or is it staying up? Does clay float? The density of clay is much greater than the density that water. A lump of clay does not float. There's a lump of clay. Although clay can float. Get some modeling clay. Place a lump of clay on the surface of the water in your bath. Does it float or does it sink? Make sure you're doing this with your grown-up. Test it out. Now let's make a float. Shape the clay into a boat. The first lump of clay sank. But now, if you made it into a float, shape the clay into a boat. Place the boat on the surface of the water. Does it sink or float? The lump of clay that the boat made from it weighed the same, but the boat takes up more space than the lump of clay because of its shape. The boat encloses air. The density of the boat and the air it encloses is less than the density of the water. That's why it floats. Okay. Look. Now, with the clay boat in the water, take a look at the sides of the boat. The boat is not really floating on the water. Part of it is underneath the surface. It's a little bit underneath. Put a few coins, marbles, or pebbles in the boat. As the boat and its contents get heavier, weighs more of the boat goes beneath the surface. See, with all the things in it, it's going a little deeper. As the clay boat sinks lower, it pushes water aside. It displaces water. The weight of the water the clay boat displaces equals the weight of the boat and its contents. I know, there's a lot of science in this. But let's read a little more. Because of the shape of the boat, part of its contents is air. The boat will continue to float if the density of the boat and its contents is less than the density of water. A lot of big scientific word that you're going to learn about later on. But look at this sailboat. Are all these boats floating? Is the fish floating? Oh, the fish is in the water. Now get some ice cubes. See if you can try this. Get some ice cubes. Drop the ice cubes in the sink. They float. Why does ice float? Ice is water, remember? Icebergs are huge, floating mountains of ice found in colder parts of the world's oceans. Look, why do ice and icebergs float? You can find the answer in your freezer. Put some water in a paper cup. Make a mark on the side of the cup to show the level of the water, like this. Put the cup in the freezer and wait until the water has completely turned to ice. The level of the ice is higher than the mark you made on the side of the cup, so it's higher. When water freezes, it gets bigger, it expands. Ice weighs the same as water, but ice takes up more space. That's why it floats. Not all water is the same. Have you ever been to a beach Was the water at the edge of an ocean or was it on a lake? Ocean water and lake water are different. Did you know that? Do you know why? Ocean water is salty. Lake water isn't. Lake water is fresh water almost, although you can't drink it. Ocean water is denser than lake water. Some things will float in an ocean, but some things sink in a lake. See, the dog is floating here in the ocean, but in the lake, it's sinking. I wonder why that is. You can prove that density of salt water is greater than density of plain water. Do a little experiment. Get an empty plastic soda bottle with a cap. Make sure you're doing it with a grown-up. Fill the bottle about halfway with water, like that. Mark the side of the bottle to show how much water is in the bottle. Now add about a teaspoon of table salt to the water. You know, like when we make Play-Doh, we use salt, so it's the same salt. Put the cap on the bottle and shake it. If you check the level of the water, you'll probably see that it did not change. What happened to the salt? What do you think? What happened to the salt? It dissolved. That's a big word that meant it just disappeared. It melted away. It dissolved. What was once plain water is now salt water. It takes up the same space, but there's more to it. If you checked, you'll find that it weighs more. The density, there's that word density again, the density of the salt water is greater than the density of the plain water. Of course, the saltier the water, the greater its density. Different things have different densities. Even different kinds of water have different densities. That's why some things float and some things don't. The end. So remember to find certain items and make that little chart where you have the 3 columns. List the items and then list what you think is going to happen, what you think is going to happen first. Does it float? The items here. Your guess, does it float? Yes, yes, or no? And then try it out and put the correct answer in, okay? And tell us all about it. Post it on Google Classroom. So nice to hear from you all. I know this was a long book, but have fun with the activity, and Miss Wu is going to be posting more activities for you to do with this book. So have a great night, and I will see you all soon. Bye. Love you. Miss you guys a lot.